Me, madam.
Okay, you may start. Okay, what's your name? Siti Husna.
Yeah.
Okay, Siti Husna. Okay, you can share screen and then present your answer. Before you present, you read the question first. Okay.
Okay. Read first.
You tell me the important point over the question 7. For the question 7.
So number 7, a 2.4 gram sample of carbon is burned in a calorimeter. Given that delta H for CO2 is negative 394 kilojoule per mole, and the heat capacity of the calorimeter is 10 kilojoule per degree Celsius. Calculate the temperature change of the calorimeter.
Okay, so now you can share screen to share your answer. Try share screen. Okay, very good. You are able to share your screen. Okay. Yeah, okay, great, clear.
Okay, so first of all, we have to write the balance equation. C plus O2 will produce CO2. Then we have to calculate the number of mole of carbon. 2.4 gram divided by 12 gram per mole. So we will get 0.2 mole. Then 1 mole CO2 will release 394 kilojoule. So 0.2 mole CO2 will release negative 78.8 kilojoule. So, then we have to choose the right equation. Then
formula.
Right formula. Sorry. Right formula. So we will choose Q equals to C delta T. We substitute all the value given. Then we will get the temperature change of the calorimeter is 7.88 degrees Celsius. Yes.
Okay, so the final answer is the temperature change of calorimeter is 7.88 degrees Celsius. Okay, very good, Siti Husna.
Okay, thank you.
Okay, others any question? Okay, step formula. Step 2, number of mole. Step 3, okay, stoichiometry comparison. Step 4, formula, and then last, final answer. Okay. Now, who's turn?
Mine, madam.
Question number 8.
Yeah.
Okay, try. Naveen. Okay, Naveen, question number 8. Share your screen. You present? Share screen? You try. Present now. You just click present now, then share your answer and then start explain. Okay, yes. Present already. Very good. Okay.
Can see, madam. Madam?
Yeah, okay. Okay, clear? Others can not?
Okay.
Madam's side is very clear. Okay, start present.
Okay, number 8. Number 8, I list down all the information of the question. So I list down, say, they give the mass of aluminium, which is 0.1326 gram. They give the heat capacity of aluminium, which is 1410 joule per degree Celsius. And they gave the temperature change, which is 1.726. They gave the mass of water, which is 800 gram. And also they gave the specific heat capacity of water, which is 4.18 joule per gram per degree Celsius. Okay, and then first we need to find the number mole of aluminium. And we can do this by using the formula mass over molar mass. So the molar mass of aluminium is 27. So we take the mass, we divide, we will get 4.1911 times 10 to the power of negative 3 mole. Next.
Okay, Naveen, very good. You will say 4.9. Naveen, stop for a while.
Okay.
You success to find the 4.1. You success to find the 4.911 times 10 to the power of negative 3 mole. But unit is missing for your answer scheme. Am I right?
Yeah, madam, I forgot to put this down.
So please take note, must write down the unit. Okay,
Okay,
yes, proceed.
Okay, next, you need to find a suitable formula. Equation. Formula, correct. So because this is involving water and calorimeter, so the suitable one will be mass of water MWCW delta T plus CC delta T.
Okay, very good. But madam need to do some correction. Okay, so you success to find the formula already, but you have to make a statement. Heat released by combustion equal to heat absorbed by water plus heat absorbed by calorimeter.
Oh, okay.
You have to write down the statement first before you write down the formula. Okay, continue. Good try.
Okay. And then when you find the heat released, so that heat release is for 4.911 times 10 to the power of -3 mole of aluminium. But then the question is asking calculate the heat of combustion of aluminium. And when we see the definition of enthalpy of combustion, it says the heat release when 1 mole. So we need to find 1 mole of aluminium. So then we'll compare and we'll get the heat release when 1 mole of aluminium.
Okay.
And then
good.
Final answer, as you can see, is negative 1670.82 kilojoule per mole. Negative is because, again, when you see the definition, it says heat release. Heat release means it's exothermic reaction, that's why it's negative. That's all.
Okay, yes, okay. Then for your conclusion, right, madam want you the delta H, right? You write down delta H combustion. Okay. So for the last part, delta H combustion equal to negative 1670. Okay. Good job. Thank you, Naveen. Okay. Next question, number 9.
Yes, madam.
After Siti Husna, after Naveen, who is the what next? Oh, Kong Sokian. Okay, Sokian, your turn. Question number 9. Okay, you can share your screen. Everybody got a chance to share screen and present. Yeah. Don't worry, you can try.
Can see right.
I think you haven't shared yet. You haven't shared yet. You have to click present now. Oh, did you? Okay. Okay. Did you press present now? I think you haven't pressed present now. Never mind. Do this slowly. You try present. Your screen just share with yourself. But for us, we can't see anything yet.
Madam, I use the phone. Okay.
Yes, you are good. Okay, you are present now. Yes. Okay, success. Yeah, just try and error, no worry. Yang lain jangan risau, cuba je. Okay? Yeah, I can see you presenting. So please show your answer. Okay, yeah, betul. So you are sharing your screen with everyone. Okay. K-pop. What's the name of this idol? Okay, no worry. Okay. Okay. Never mind. It's better compared to just now. Okay, never mind. You just try. You just explain. So how to solve?
The link on the question already. Okay. The question given is the formation of the naphthalene used to calibrate the capacity of a bomb calories. So we have from this question is we have a calorimeter. So we get the since that we can use the equation is the heat release if
Okay, Madam, take over Kong Soo Kian presentation because her line is quite weak.
to
Okay. Oh, Madam, take over your presentation.
MW
Okay, no worry.
Count the number of mole of the naphthalene first. Use the 0.8210 overall of
Okay, so just now we can listen, right? Okay, Kong say about, okay, have to find out the number of mole for the naphthalene. Okay, Madam encourage you all write down with 4 decimal places. Actually, the proper one is 3 significant value, but I encourage you all get the 4.6161 times 10 to the power of -3 mole of the number of mole of naphthalene. And then don't forget, okay, even though for this case, the equation is not really important, but I want you all get used to it. So, naphthalene C10H8 solid react with 12 mole of oxygen gas and then produce 10 carbon dioxide gas plus 4 water liquid. So this is the equation for this question. After that, based on the question given, 1 mole naphthalene equivalent to 5132.8 kilojoules. So based on this number of moles of this reaction, right? So the number of the heat release is 32.922 kilojoules. Okay, based on the information given, you know, heat released by this combustion reaction is absorbed by the water and the heat of calorimeter and absorbed by the calorimeter. That's why we are applying this formula. So just substitute everything. And then formula 5 is the final answer or conclusion. Please jot down. Okay, class, while you mark the question, right, you please state step 1, step 2, step 3, step 4, step 5. When you get used to the steps, right, no problem for you all to solve the problem related with calorimetry. Ya, semua orang sila catatkan langkah pertama, kedua, ketiga, keempat, kelima. Okay, you akan mendapati langkah dia, step dia memang lebih kurang sama je. Okay, kalau dapat soalan you tak faham, jangan panik. Okay, ingat balik Madam ajar macam mana. Step 1, equation, persamaan ada tulis ke tak. Lepas tu ada apa maklumat untuk mencari bilangan mole. Kemudian comparison, stoichiometry. Adakah informasi 1 mole berapa kilojoule diberi? Ataupun soalan nak cari 1 kilojoule kemudian yang N mole ini meriliskan berapa mole, biasanya dia akan suruh you bandingkan secara stoichiometry. Then, detect. Heat release akan diserapkan oleh air ke, oleh calorimeter ke. Lepas tu formula substitution, final answer with unit lah. Okay, next we proceed question number 10, Jason. Okay, so I stop now. So Jason, present. Okay, now Jason, your turn. You can share your screen, present now. Okay. Okay, so just now Nervin and Husna did a good job because they're able to share their screen. Okay, so Kung, you have to learn how to share the screen. If I ask you to present. Okay. No. Others? Yang lain nampak tak? Jason share screen, macam tak nampak?
No, madam.
Tak nampak lagi. No. Try again. Yeah, you're presenting now. Okay, good. Okay, I can see your answer already. Okay, start your presentation. Jason? Okay, over here, right? Your final unit, no problem. You know what is the mistake of the final unit? Negative 48.77 kilojoule per mole. Okay, because this one is referred to 1 mole of water form, right? That's why the final unit is negative 48.77 kilojoule per mole. Please take note. Okay, very good. Okay, please everybody please look at Jason's answer. Okay, the part that he highlighted, heat released by reaction equal to heat absorbed by solution. So over here, the heat absorbed by solution is the HCl plus sodium hydroxide. So total volume is equal to 350 ml. Okay, over here, right, we need to determine which one is the limiting reactant. Okay, over here we need to determine because the volume given by sodium hydroxide and then the volume given for the hydrochloric acid is different. Okay, even though both of them having the same number of moles, same concentration. So you have to determine the limiting reactant. Okay, very obvious. Okay, the less volume is produce the less amount of number of moles, which is HCl. That's why we need to compare with 1 mole of HCl. So over here, please write down one more statement. Okay, after the limiting reactant is HCl. Because NaOH is 0.2 mole. And then HCl is 0.15 mole. Okay, madam shows the thing. Okay, good try, Jason. Okay. Okay, madam. Madam, then. Please take note. Okay, step 2. No, step 2. What I say. Step 2. You find the number of mole for sodium hydroxide. You find the number of mole of HCl. And then over here you compare which one is the limiting reactant. So obviously HCl is in. That's why to compare with HCl. So 0.15 mole of HCl react 0.15 mole of sodium hydroxide to produce 0.5 mole of water. Okay, no problem. And then make sure the final answer is joule per mole. So step 2, step 3, ruler, step 4, stoichiometric comparison, find answer with correct unit. Okay, thank you, Jason. Very good. Next, question 11.
Me, madam.
Question?
Me, madam.
Yeah. Okay, next presentation. Present now. Who are? Okay, Shah. Okay, Shah, question number 11.
Can you see, madam, my screen?
No, I think sound is not clear. Okay, Shah is presented, but you haven't put your answer yet.
No, madam.
Okay, Shah, try again. And can your screen is not sharing. Your screen is sharing, but your answer is not sharing. Okay, try again. Okay. 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 Yes. Okay. Okay. Can Madam can see your answer?
Okay.
CH4. This is CH4. Yeah, CH4 react with oxygen and then produce CO2 plus H2O. So this is the thermochemical equation. Okay, Shah, you can start present now.
Okay, so my given question is, if someone wanted to boil 2 kilograms of water at 20 temperature in a kettle, what mass of natural gas must burn to raise this quantity of water to 100 degrees Celsius. So by this, the mass of water is 2 kilograms, and then the difference in temperature is 80 degrees Celsius, which is equal to delta T. And then the specific heat capacity also is given, 4.18. And then the heat of combustion is 890 kilojoule per mole, which is 1 mole is equal to 890 kilojoule. So
Okay, very good. Okay, Shah, analyze the answer, analyze the question yet. Okay, very good. Then proceed.
Okay, so first step is do the equation CH4 plus 2O2 will produce CO2 plus 2H2O. And then produce delta H is equal to negative 890 kilojoule per mole because it is combustion and exothermic. That's why it is. And it is combustion is equal to heat absorbed by water. So we use the formula Q equal to F theta. C is the capacity. So Q is equal to 4.18 times by 80. We get Q is equal to 668.8 kilojoule. And then 690 kilojoule is equal to 1 mole. So 668.8 kilojoule is equal to 0.7515 by using stoichiometric method. And then we get 0.7515 mole, and then we have to use the formula mass over molar mass to find the mass of CH4. Then we get 0.023 kilogram.
Okay, very good. Clear explanation. Okay, and then the step very clear. Step 1 equation, step 2 formula, step 3 comparison with stoichiometry method. Step 4 satisfy the number of mole, then time molar mass, and then answer the question. Very good. Okay, thank you, Shah. Okay, next question number 12. Question number 12, Hess law. So we move to 2.3 Hess law. So the first question is the definition. I think should be no problem. We straight away go for 12B. Houston. Okay, Nu Atira. Okay, try to share screen.
Can you see my screen?
Yes, very clear. Good.
Okay. So the question is calculate the heat change for the reaction. For this equation, first, the equation given is here. The equation that we want is 2C plus oxygen we get 2 proton monoxide. So first is if we see here, there is 2C. So in first equation, we need to find 2 for the equation and for the enthalpy. Second, if we see here, there is 2CO and it is in the right. So we need to reverse the second equation and times 2. For the enthalpy, we need to times 2 also, and for the enthalpy there will be duplicate. And we will get 2C plus 2O2 from 2CO2. The enthalpy is negative 786 kilojoule. And for the second equation is 2CO2 from 2CO plus O2. And the enthalpy is plus 496 kilojoule. Then for the final enthalpy 1 plus enthalpy 2, we will get negative 290 kilojoule.
Okay, very good. Okay, madam just want to make some correction. For the last one, enthalpy, not formation, is enthalpy of reaction. Okay? Okay, madam show a bit. Okay, her working is good. Her working is all good. Okay, just the last part. Okay, madam share a bit. Okay, very good, Atira. Okay, so class, okay, oh, you're right. Okay, I encourage you, all right, when you after, okay, for the first equation, after you times 2, and then the second equation, reverse and times 2, okay, you get the answer. And then last one, we write down as enthalpy of reaction. Okay, you can write down the short form RXN, okay, or you write the full term also, no problem. And then you try to circle the reactant and product that you want so that you won't miss. And then the rest, make sure can be cancelled off, okay? So 2CO2 cancel, and then here 2 oxygen, here 1 more oxygen. After cancel 1, remain 1 oxygen. Okay? Clear? You can try to do like that. Yes?
Madam, the unit not kJ per mole.
No, in this case, no. You know why? Okay, Atira, please share your answer again. Atira, please share your answer again. Okay, you check. Okay, everybody please look at the B. The B, the listed one. Yes, the listed one, negative 393 kilojoule per mole, because it's referred to 1 mole of CO2. And then the second equation, negative 248 kilojoule per mole, is referred to 1 mole of CO2. But after you times 2, reverse times 2, right? Okay, now the equation no longer refers to 1 mole. That's why the final answer for the enthalpy 1, enthalpy 2, and then the enthalpy of reaction is kilojoule. Clear, Nabi? Okay, semua orang boleh faham? Okay, be careful. Okay, per mole is referred to 1 mole. Over here, change already. The whole equation times 2, reverse times 2 is no longer to refer 1 mole. Okay, very good. At least you alert. Okay, be careful about the unit. Okay, good. Proceed for question 13. Who's turn? Thank you, Atira. Thank you, Naveen.
Saya madam.
Siapa dia? Tengok. Oh, Muaz. Okay, Muaz soalan 13. Okay. Sebenarnya soalan 13 bonus kalau tengok video madam memang sudah terangkan soalan 13 dan 14 juga. Tapi you cuba terangkan sekali lagi. Okay, macam mana nak menyelesaikan soalan 13? How to solve question 13? Yeah, try to share screen. Okay, good. Your working seems like not complete. Okay, never mind. Just proceed and see.
Dia
Okay,
kata
cuba.
dia bagi N2H4 liquid tambah O2 gas jadi N2 gas tambah dengan 2H2O gas. Tapi yang dia nak ni jadi steam bukannya gas. Lepas tu yang kali yang
Steam
second pula dia
dan
bagi
gas berbeza ke? Sekejap. Muaz, steam dan gas berbeza ke?
dia nak gas.
Dia nak gas ke?
Tapi dia nak tak lah dia liquid tapi dia bagi gas
Yes, dia nak liquid tapi bagi gas. Okay, sambung.
Lepas tu kat bawah ni dia bagi H2O liquid jadi H2O gas dia tambah 40 kJ, 40.7 kJ. Tapi kita nak jadikan yang liquid so kita pusingkan dia jadi negatif 40 kJ. Dia kena darab 2 sebab dia nak 2H2O.
Okay. So maksudnya equation pertama apa? Equation pertama? Ada buat apa-apa ke tak?
Tak payah.
Okay, tak payah. Itu enthalpy 1. Okay, enthalpy 2 apa yang anda lakukan?
Reverse kena darab 2.
Okay, reverse darab 2. Okay, lepas tu campurkan. Okay, berdasarkan penyelesaian anda, okay, yes, you dapat jawapan yang betul. Okay, you agak-agak dapat dah equation yang last kali. Tapi ada kekurangan terhadap jawapan anda. Bolehkah anda sebut apa kekurangan jawapan anda?
Kekurangan?
Kalau you bandingkan jawapan anda dengan Atira tadi, apa yang you kurang?
Kurang apa lah?
You nak Atira tunjuk sekali lagi ke tak? Kemudian bandingkan. You bandingkan jawapan anda dengan Atira. Okay, Madam Atira, tunjuk sekali lagi jawapan anda bagi Muaz tengok. Silakan Atira.
Okay, Madam.
Muaz bagi tengok. Penyelesaian anda dengan Atira, apa kekurangan anda? Atira akan dapat markah penuh, tapi you jawapan betul, tapi tak dapat markah penuh. Apa kekurangan anda? Okay, bandingkan. Okay, you tengok penyelesaian dia. Nampak tak? Ya, enthalpy 1, enthalpy 2 tulis dengan jelas. Lepas tu enthalpy reaction pun tulis. Okay, formation tukar reaction. Selepas substitution, dia pun tulis formula. Lepas tu dapat jawapan akhir. Apa kekurangan anda? Okay, Muaz, Madam bagi 1 minit you betulkan yang kekurangan anda, kemudian share screen. Muaz, nampak ke tak? Apa perbezaan anda dengan Atira? Halo, Muaz?
Yang dia punya tu lah, dia punya simbol lah.
Simbol, betul. Okay, kalau you tak nampak lagi, Madam share sekali lagi. Okay lah, Madam tolong anda lah tengok. Aisyah lah, tengok Atira. Contoh jawapan yang paling bagus hari ini, Atira. Okay. Okay, Madam punya tak lengkap Madam punya tak lengkap. Okay, tapi Madam tambah sekarang. Okay, first, adakah anda label enthalpy 1, enthalpy 2? Muaz, adakah anda label? You tak label kan betul? You terus enthalpy 1, enthalpy 2 je. Okay. Okay, you kena tulis ini. Ini adalah penyelesaian yang satu lagi. Okay. So, you kena buat satu garis macam ni. Okay, you satu garis. Okay, ini you nak dapat jawapan dia. Satu garis. Okay, kena. Lepas tu double line. Okay, satu garis lagi kat bawah sini. Ini jawapan akhir. That's why double line. Okay, first, semua orang take note mesti write down enthalpy 1, enthalpy 2. Lepas tu, Apa yang you nak bulatkan? I nak N2, ni I nak, ini I nak, ini I nak. Tak nak tu pastikan dapat cancel off. Lepas tu jangan lupa yang last kali ialah enthalpy of reaction. Okay, so terus tulis capai ni pun tak apa. Dan ini perlu tulis semula. Formula, substitution, final answer. Everybody clear? Question 13, question 12, how to solve the problem and perform your answer in the correct way ya. Jelas semua orang? Betul kan? Wajib tulis. Wajib. Okay, for all the questions, no matter using Hess law, algebraic method or energy cycle method, this part is a must. You must show the formula for the enthalpy, and then substitution, final answer with correct unit. If exothermic with negative sign, is endothermic with positive sign. Okay, shall we proceed for question 14?
Yes, madam.
Yeah. Huh? Okay, who's done question 14?
Me, Madam Ardini.
Okay, Ardini, okay. Let's start with your question 14. Okay, need to perform this question by using energy cycle method. Okay, try share your screen, Ardini.
Okay. Can you see, madam?
Yeah, can.
According to the question, there are two equations given with the enthalpy, and the equation asks to calculate enthalpy for the following reaction using energy cycle method. First, oh my god.
Why? Slowly. Yes, very good.
First, we need to draw the energy cycle diagram first. And write the equation S plus 3 over 2 O2 and produce SO3. And after that, we use the information given with the two equations that S plus O2 will produce SO2 and the enthalpy is negative 297 kilojoules. I label it as enthalpy 1. And then the second equation, SO2 plus half O2 will produce SO3 and the enthalpy is negative 99 kilojoules and it is labeled as enthalpy 2. And to calculate the enthalpy reaction equal to enthalpy 1 plus enthalpy 2 and substitute the value negative 297 kilojoules plus negative 99 kilojoules and the final answer is negative 396 kilojoules.
Yes, correct. Very good. Clear explanation. And then screen also clear. Okay, any question do you want to ask others? Ada soalan tak? Okay, penerangan dia jelas tak? Okay, jawapan pun jelas. Okay, thank you Ardini. Tak ada? Okay, let's proceed to question 15. Okay, there are three equations given by question 15. And then use the above data to calculate the enthalpy for the reaction. So who's done question 15?
Me, madam.
Okay, Ama Aiman. Okay, Ama, share screen. Please share your screen.
Yeah. And I present.
Okay, Ama.
Can you see, madam?
Cuba zoom sikit. You memang present tapi kurang kerana terlalu kecil. Okay, you zoom sikit, nampak sikit. Okay, yes. Okay, good try. You kena gerak-gerak sikit lah. Okay, start.
Yes. For the first equation, okay. Dia bagi 3 equation. Tak tiga dan dia nak equation dia 2HCl tambah F2 menghasilkan 2HF tambah Cl2. Jadi kita nampak equation pertama tu dia ada dah 4 HCl. So kita tekankan HCl tu, tapi sebabkan dia 4 kita kena bagi 2. Jadi kita dapat
bagi 2, betul?
So kita dah bagi 2 equation, kita kena bagi 2 dia punya enthalpy juga. Lepas tu untuk second equation dia nak 2HF. Dekat bawah tu dia nak 2HF. So HF tu saya reversekan dia sebab HF tu belah kanan. Saya kena reversekan dia dan juga darab benda 2 untuk dapatkan 2 HF.
Betul?
Dah reverse dan darab 2, so enthalpy pun kena tukar unit dan juga darab dengan 2 juga.
Bukan tukar unit, tukar tanda.
Tukar tanda. Tanda. Okay, so untuk equation dia nak apa, ada CL, ada F2. F2 CL. So tak apa, itu kena terbalikkan juga untuk dapatkan equation yang dia nak. Kalau tak terbalikkan tak dapat lah. So kalau dah terbalikkan, dia punya tanda pun kena tukar. Lepas tu kita potong je lah apa yang sama tu. Lepas tu dapat yang tu, kita tambahkan semua enthalpy kat kanan tu. Enthalpy ni semua kita kena tambahkan.
Betul? Aman, jap. Pergi enthalpy anda semula. Enthalpy, besarkan sikit. Okey, apa kesalahan kat sini? Beritahu madam.
Saya tak ada
Segi 3 sudah hilang. 1, 2, 3 tak label. Alert Segi 3 enthalpy H1, enthalpy H2, enthalpy H3. Yang last kali itu ialah enthalpy reaction. Okey ya.
Kalau saya tulis enthalpy formation tak boleh madam?
Untuk case ini dia bukan formation, dia tak merujuk mana. That's why kita guna reaction. Kalau soalan pagi itu ialah enthalpy formation untuk certain compound, yes kita boleh. Tapi untuk case ini dia untuk for the reaction. Nampak tak? Soalan use the above data to calculate enthalpy for the reaction. That's why kita tulis enthalpy of reaction alert
Alright.
Okay ya.
So kita tambahkan enthalpy 1, enthalpy 2, enthalpy 3. Kita dapatlah jawapan dia negatif 988.4 kilojoule.
Yes. Okay, Tanya, betul. Okay just minor mistake. Good try. Okay, yang lain boleh ke tak boleh? Jelas? Nak madam ulas sekali lagi ke tak payah? Jelas. Okay, thank you Rabiato. Jelas. Okay, kalau jelas kita pergi soalan yang paling susah, 16. Siapa dia? Thank you Ama.
Alright madam, thank you.
16 siapa?
Saya, madam.
Oh, Christina. Okay, Christina 16. Okay, tunjukkan jawapan anda. Inilah paling rumit sekali. Antara semua soalan ni dia paling complicated. Kerana equation dia tak bagi. You kena tulis sendiri. Okay, cuba share your answer. Try to share your answer.
Madam, saya keluar.
Apa? Tak keluar ke? You sudah tekan present now ke belum? Okay, you sudah tekan sekarang. Okay, yes. Nampak handphone anda.
Okay.
Sekarang, okay, dia tunggu sekejap. Nampak dia tunggu sekejap. Okay, kemudian klik zoom. Okay. Yang lain nampak ke tak?
Nampak je.
Nampak. Jelas ke tak? Jelas?
Kurang jelas.
Kurang jelas. Madam pun nampak kurang jelas. Okay, cuba zoom sikit. Okay, Christina, cuba zoom sikit. Okay, ataupun you nak panduan Jason? Jason share your answer atau kemudian you terang. Halo, Christina.
Yes, madam.
Okay, kerana kurang jelas jawapan. Okay. You cuba lagi? Tak apa, cuba lagi. Okay, Christina? Okay, share sekali lagi.
Yes, madam.
Okay, you dah share tapi tak nampak jawapan lagi. Jason, maybe you need to stand by for her answer. Not clear.
Clear dah.
Tak clear ke tak clear? Jason, are you here? You try to share her answer, you see? Question 15. Question 15. 16. Okay, tengok Kerana madam tunjuk madam terus bagi jawapan semua dah. Okay, Jason share your answer. Okay, very good, clear. Okay, Christina cuba terangkan, okay? Sedang screen clear dah. Okay, thank you Jason. Christina, cuba terangkan. Okay, jawapan ni jelas.
Soalan tadi, when plant of Paris calcified half H2O is mixed with water, it combines with water to produce gypsum calcified H2O. The reaction is exothermic, which explains why a plaster cast on a broken lake comes and harden. Saya jawab because bonds are formed in this process. Enthalpy of product is less than enthalpy of reactant. So the heat is released from the system to surrounding. The reaction is exothermic.
Okay, good. And then how are you going to solve the, how are you going to calculate the enthalpy? So very good. I saw you first write out the targeted equation and then sambung.
And then need to write all the thermochemical equation. So the first thermochemical equation is calcium plus sulfur plus 9/2O2 plus half 2.
Okay, madam wants some
calcium sulfate.
Okay, stop a while. Madam want to do some correction. Actually, that day not 9/2. You see, if 9/2, if you cancel off, right, total is 9 oxygen. Okay, but over here just 4 plus half. So just 4.5 oxygen. You look at the product side just 4.5 oxygen. That's why suppose it's 9/4. Class, please take note the equation 1, calcium, sulfur, and 9/4 mole of oxygen. 9/4. 9/4 baru akan dapat 4.5. Okay ya? Okay, minor mistake, never mind. Okay, good.
Okay.
Sambung?
Okay. The second thermochemical equation is calcium plus sulfur plus 6/2O2 plus 4/2H2. We produce calcium sulfide 2H2O.
Okay, yes, this one no problem, correct?
Okay, that one. 3/2H2 plus 3/2O2, we produce 3/2H2O.
Okay, so same mistake. Suppose it's 3/4 oxygen. 3/4. Okay, setiap kali you tengok kanan 3/2 oxygen, dia satu je. Maksudnya kat produk 3/2 oxygen. Tapi kat sebelah reactant 3/2 O2, maksudnya dia 3. Satu ialah O2, satu ialah O. Jadi berbeza, kanan kiri tak balance. So kalau nak balance, jawapan dia ialah 3/4 oxygen. 3/4 kesalahan dia sama dengan 1. Okay, good. Sambung.
Okay. So for the first thermochemical equation, the delta H given is negative 1573 kJ per mole. But when we refer to the target equation, the calcium sulfide half H2O is at the product at the reaction. So we need to change the sign from negative to positive sign. So delta H1 will be 1573 kJ per mole.
Tapi you tak tulis positif. Jadi betul ke salah?
Oh, salah.
Positive sign insists, okay? Positive sign insists, okay. Sambo?
For the second thermochemical equation, there is no change for the equation because the mole is still the same and the position for calcium sulfide with 2O is at the product, same as the target equation. So the delta H2 will remain the same, is negative 2020 kilojoule per mole.
Okay,
And then
so
for
again, same mistake, you forget. Again, same mistake, you forget the positive sign as well, Okay, positive 439.5 kilojoule per mole. So lastly,
the third one, we need to sum up all delta H1, delta H2, and delta H3. So the delta HRXN will be negative 7.5 kilojoule per mole.
okay, good. Okay, Madam share with you all. Actually, there is another method. Thank you, Christina. Good try.
Thank you, Madam.
Okay, everybody, please check with your answer. Okay, so just now, Christina, okay, please take note. Okay, here is 9/4 oxygen, then here is 3/4 oxygen. So please make sure that you label enthalpy 1, enthalpy 2, enthalpy 3, and then after that, last one is enthalpy of reaction. Okay, again, for this whole thing, right, you need to rewrite again. You need to rewrite so that you can get negative 7.5 kilojoule. So this one double line, enthalpy of reaction. So this is by using Hess law method. Another one is formula. If the question just around 3 marks or 2 marks, so you just need to use this formula. But please take note, this formula just applicable for the enthalpy of formation. Okay, for this case, because stated enthalpy formation of calcium sulfate half water, calcium sulfate 2 water, and then enthalpy formation of water. So that's why we can apply this formula. So the enthalpy of formation of product, this one, calcium sulfate, okay, with negative 2020, and then minus the enthalpy of the reactant for these two. And then you get the answer, negative 7.5. Okay, so this is another method to solve this problem. But this one you must know how to solve it. Okay, you have to know how to write down the equation by yourself. List down the equation by yourself. Okay. Okay, please jot down the answer and then please correct your answer as well. I give you around 1 minute for this question. Okay. Okay, semua orang jot down jawapan ni at the same time we take 5. Okay. Okay, who's turn now? Question 17.
It's medium. Exactly.
Okay, Izati. Okay, so Izati, you can share your screen now for question number 17.
Medium, can you see the screen?
Yes. Can.
Okay.
That label 1, 2, 3, 4, 5. Must label enthalpy 1, 2, 3, 4, 5.
Oh, sorry, medium.
Yeah.
Okay, for question number 17, it states that acetylene is a gas used in welding torch. It is produced by the action of water on calcium carbide, and calculate the enthalpy of formation for acetylene in kilojoule per mole by using the thermochemical equation given. So the question asks for the enthalpy of formation for acetylene. So we have to write the equation for acetylene, and we will get 2 mole of carbon react with 1 mole of hydrogen gas, we produce 1 mole of acetylene. So in order to get the acetylene equation, we must compare with equation 3, since equation 3 have acetylene. And then the enthalpy for equation 3 will equals to negative 126.0 kilojoule. And then we compare it with equation 1. For equation 1, we must reverse the equation because CaOH2 in equation 3 is on the right side, while for equation 1 is on the right side too. So we have to reverse it to make it on the left side, so we can cancel it out.
Yeah.
So
Correct.
As we reverse it, the enthalpy for equation 1 will equals to 65.3 kilojoule. So we will convert the negative signs of equation to positive sign since we reverse the equation. And then we compare it, and then we cancel H2O 2. So in equation 3, the mole of H2O will only have 1 mole. And then we compare it with equation 2. Since CaO in equation 1 is on the right side and equation 2 on the left side, so we can cancel it out, so we don't have to reverse the equation. So we get the enthalpy is equals to positive 462.3 kilojoule. And then we can cancel CaC2 in equation 2 and equation 3. And then we compare it with equation 4. We must reverse the equation 4. And we can cancel carbon.
So what are you going to do for equation 4? Yeah, reverse equation 4. And then the last one.
And then cancel carbon. Okay, cancel carbon in equation 2. So equation 2 will have 2 mole of carbon only. And then we will get enthalpy equals to positive 220.0 kilojoule. And then we compare it with equation 5. So for equation 5, we must reverse the equation and divide it by 2, since the oxygen gas in equation 4 is half of the oxygen gas.
Okay, correct.
So in order to get the half mole, we must divide the equation 5 by 2. And then we will get the enthalpy is equals to negative 572.0 divided by 2 kilojoule. So as we cancel it out all the equation, we will get 2 mole of carbon plus with 1 mole of hydrogen gas, and that will produce acetylene, 1 mole of acetylene. And then to get the enthalpy of formation for acetylene, we must plus all the enthalpy that we get, and we will get 335.6 kilojoule per mole.
Okay, good. Okay, so you notice that one part, the last part, something missing. Can you tell me what missing?
Last part.
The last final answer.
Oh, the positive sign.
Yes. Okay, you forget the positive sign. Okay, positive sign is this. Okay, good. Okay, okay. Thank you. Thank you. Who just now who is the one who presented? Izzati. Okay, thank you, Izzati. So let's check. I don't want to show my answer with you, or you just double check. Okay. So the explanation from Achira Izzati is clear. Okay, but I want to just double confirm with you all. Okay, so can you all check see my answer? Yes or no? Okay, can you see my answer for question 17? Semua orang nampak tak? Jawapan Madam soalan 17 ada share ke tak? Tak nampak. Sekejap.
Tak nampak, Madam.
Tak tekan lagi. Okay. Okay, nampak?
Nampak.
Okay, so double check apa yang Izzati buat tu betul, hanya just minor mistake. Okay, so make sure that you write down. Okay, label 1, 2, 3, 4, 5. Okay, so this one reverse. This one remain the same. Okay, the first one is reverse equilibrium, and then this one reverse and times half. Okay, semua kena buat semula. And then last kali, Madam tak banyak kali cakap. Okay, circle the answer that you want. Okay, tadi Izzati ada terang satu demi satu. Dia memang terang satu demi satu dengan jelas. Okay, here 3 more, here 1 more. That's why cancel off, remain 2. So that's why 2 more. Okay, this is the targeted equation that you want. That's why you, okay, double line. The rest, make sure you can cancel off. Okay, pastikan yang tinggal tu mesti boleh cancel off. Jom kita sama-sama half oxygen, and then, okay, check 1 more water, 2 more water at the product side, cancel with the 2 more water at the reactant side. Okay, calcium hydroxide, calcium chloride, calcium oxide, here calcium oxide, CO. Okay, make sure the component that you don't want, make sure can cancel off. Okay, so this is the targeted equation. Please write down. Okay, over here we write the enthalpy of formation. Tadi Madam cakap tak boleh, tapi untuk soalan ni boleh kerana soalan tu memang tulis calculate the enthalpy of formation. Jadi ikut je. So jangan lupa formula, substitution, final answer with correct unit. Positive sign insists unit is kilojoule per mole because over here is refer to 1 mole of acetylene, C2H2. Clear? Jelas? Okay, Madam nak you all semua jawab ikut sebiji skema. Okay, jangan 1, 2, 3 sudah hilang, jangan tak ada negatif positif sign ataupun unit salah. Jonah, okay, follow exactly ya. Okay, so that's all for 2.3 Hass's law. Now we proceed for 2.4 Born-Haber cycle. There are 5 questions. Okay, question 18 and 19 is about dissolution process. Okay, whose turn? Siapa? Jangan nak Madam pergi tengok saudara ya. Siti Aisyah. Aisha, are you here? Seems like not here. Okay, never mind. Who for question 19 first? Question 19. No, Aisha.
Me, madam.
No, Aisha first. Question. Oh, Siti Aisha ada. Okay, Siti Aisha, 18. Okay, present. Share your screen for question number 18. And then Nu Aisha get ready nanti ya, 19. 20, Nu Syahira.
Madam,
Ya,
saya.
present. Anda boleh present sekarang, Siti Aisha. Share screen.
Madam.
Ya. You share screen, present lah. Kami tunggu anda.
Okay, I'm sorry.
Kami
tadi
sedang
dia
tunggu anda.
terpadam.
Just present.
Okay.
Okay, yeah, you are sharing.
Okay.
Soalan.
So, the question is about dissolution process. The lattice energy of NaCl is minus 776 kJ per mole, and the enthalpy change when 1 mole of solid NaCl dissolved in water is positive 4 kJ per mole. If the enthalpy of hydration of Na plus is negative 390 kJ per mole, calculate the enthalpy of hydration of Cl negative in the dissolution process of NaCl using the energy cycle. Oh my god. Okay, so the question asks about the enthalpy of hydration of Cl negative. Wait. Tidak. Madam.
Yeah.
I'm sorry, I don't put the cycle. I forgot to put the cycle.
Okay, apa? Madam bagi masa you pergi snap, kemudian snap dulu. Okay, kita buat 19 dulu. Okay, kita buat 19 dulu. You pergi snap nanti present Okay. So question 19 first. Okay. Question 19 Nu Aisyah dulu. Okay, Siti Aisyah pergi snap energy cycle anda. Okay. Nu Aisyah 19 dulu.
Yes. Saya share screen
Share screen. Ya, terus share je.
Okay.
Okay, nampak? Boleh?
Okay. From the question, it's when lattice energy.
Ini suara tak jelas. Nu Aisyah tengok suara mengapa tak jelas Check semula.
Can you hear me, madam?
Yeah, but quite low. Never mind, you try continue.
Okay. From the question, it given lattice energy for potassium fluoride is negative 821 kilojoule per mole, and enthalpy of hydration is negative 819 kilojoule per mole. So we must find enthalpy of solution. So this is my energy cycle. So sheet it is delta H solution equal to negative delta H lattice plus delta H hydration. So we just put the delta H and we will get positive 2 kilojoule per mole.
Okay, apa yang Nur Aisyah buat tu betul, tapi you all faham ke tak?
Yes.
Okay, terima kasih Nur Aisyah. Okay, cara dia ialah dia guna formula. Dia guna formula. Tapi guna formula, you all boleh faham ke tak faham? Okay, madam tunjuk Okay, my method is using Hess law method. Okay, Hess algebraic method. Okay, if I want to transform this answer to energy cycle method, actually it's the same. Okay, but first of all, right? Okay, we must know this is the enthalpy of solution. Okay, enthalpy of solution given lattice energy for potassium. Lattice energy means potassium ion gas, chloride gas. Okay, from this one, this is lattice energy. So I give it at enthalpy 1. Okay, enthalpy of hydration is the gaseous ion dissolved in water from the aqueous ion. I give it as enthalpy 2. Okay, over here, and then calculate the enthalpy of solution. Solution means, okay, this one dissolved and then form the aqueous solution. Okay, meaning that I need to find out Kf. Okay, this one dissolved in water from K plus aqueous plus F negative aqueous. So this is the definition for enthalpy of solution for potassium. Okay, but okay, for this one I straight away I can find the answer. For the first one I reverse. That's why positive, and then the second one remain. Okay, that's why negative. So this is the equation that I want. This one is the equation that I want. This one is the equation that I want. So I cancel off, cancel off, cancel off. Okay, so we get the answer. So which is positive 821 minus 819. You get positive 2 kilojoule per mole. Okay, because it's referred to here. The 1 mole of potassium chloride dissolved in water from the potassium ion and chloride ion. Okay, if I want to use the energy cycle method, okay, can or cannot? Can, no problem. But you have to stick to definition. Okay, I will start with. Okay, I will start with lattice first. Okay, plus Cl negative gas, and then form. Oh, not Cl. Sorry, it's F. Okay, I'm showing two methods. Now I'm showing the second method. So this is F negative, so it's Kf solid. So this is lattice energy. So lattice energy, what is the value over here? Negative 821 kilojoule. Okay, of course, don't forget write that enthalpy H1 equal to Okay, next. Gaseous ion hydrated in water. So A plus aqueous. Okay, all of you are with me? Yes or no?
Yes, madam.
Yes, madam.
Okay, so next the definition according to hydration. Okay, gas dissolved in water from the K positive. Okay, handwriting is very ugly, but I hope you all can see that. K positive aqueous from the K positive aqueous. Okay, so this is hydration. Hydration means both of them is negative 819 kilojoule. Okay, so this is enthalpy 2. Okay, equal to and then the last one. Okay, according to definition of solution, is 1 mole of ionic compound dissolved in water. That's why the arrow should be like this. So this is the enthalpy of the reaction. So this is enthalpy of the reaction. Okay, so now you check. Okay, now you check the arrow. So it's like this. Okay, here like this. So meaning that enthalpy of meaning that the enthalpy of the lattice energy formation plus the reaction equal to hydration. Madam ulang, kalau tengok anak panah akan nampak destinasi akhir ialah kat sini. Potassium aqueous and chloride aqueous. Destinasi kat akhir kat sini. Jadi maksudnya enthalpy of lattice energy campur enthalpy of solution. Kat sini adalah enthalpy of solution sama dengan enthalpy of hydration. Kalau saya nak buat formula saya ialah apa? Formula saya ialah enthalpy of H1 plus enthalpy of solution sama dengan enthalpy of hydration. Maksudnya enthalpy of hydration lah enthalpy H2 lah. Hydration ialah sama dengan enthalpy of H2 lah. Okay, sekarang enthalpy H1 ialah berapa? Negatif 8, 2, 1. Campur ini kita tak tahu. Okay, yang ini kita tak tahu. Yang ini sama dengan negatif 8, 1, 9. Okay, madam sekarang tanya. Jadi enthalpy solution adakah sama dengan 2? Lepas tu pundar ke sebelah kanan. Hello, kelas? Tak faham. Okay, clear or not clear? Okay, my question is here. I dah sampai sini dah. Sekarang kalau I nak cari ni, I want to find this one. So I need to move over here. Here is negative sign. After I move to here is plus 8 to 1. That's why my answer is still the same. Positive 2 kilojoule per mole. Okay, positive 2 kilojoule per mole. So maksudnya tak kira saya guna cara ini ataupun saya guna cara ini, memang ikut definisi. Okay, I substitute macam ni mana jawapan pun masih sama dengan positif 2 kilojoule per mole. Jadi jawapan Nu Aisyah kan? Tadi jawapan Nu Aisyah pun betul, tapi Nu Aisyah guna formula. Okay, madam guna konsep. So up to you guna cara mana pun boleh. Okay, yang cara tu mengapa dia akan reverse kerana tengok anak panah dia, you tengok kisah ini dia berbeza dengan saya. Kerana dia tak ikut definisi. Tapi kalau you tak ikut definisi boleh ke tak boleh? Boleh. Tapi kena pandai-pandai juga tanda. Kerana you sudah reverse the equation, that's why you need to change the sign of the enthalpy. Okay, so please jot down. Madam show the algebraic method and show the energy cycle method already. So please jot down. Kalau tak clear energy cycle method sebab dia macam ni je. Dua soalan sama je. Okay, so this is question 18. Nampak tak? Konsep dia sama. Ini lebih jelas kerana ni dari gambar aja. So nampak tak? Enthalpy of lattice energy plus enthalpy of solution equal to enthalpy of hydration. Kita vector dia, kita kena destinasi akhir semua kat sini. This is the final destination. So that's why hydration of potassium, sodium ion plus hydration of chloride ion equal to lattice energy plus the enthalpy of solution. Okay, so nampak tak? Ini madam buat. Lattice energy, sekarang saya nak lattice energy kan? Maksudnya sekarang lattice energy adalah hydration ni campur hydration ini, okay, tolak ini. Kerana dia sudah reverse. Dia pergi sana akan jadi tolak. Asalnya ialah macam ni. Lattice campur solution akan sama dengan dua hydration. Ya, mereka guna mouse je tulis. Enthalpy of hydration of chlorine plus enthalpy of hydration of sodium. Okay, so please check the answer. Okay, any question you want to ask? So that's why question number 18, right, and question number 19. We have to try both methods. One is energy cycle method, another one is test algebraic method. At the same time, you also can apply the formula method. But no matter which method, you get the same answer. As long as your answer is correct. Okay, anyone want to ask question? Apa soalan nak tanya pasal T solution process? Ada soalan nak tanya ke tak? Tak ada. Tak ada maksudnya nanti I bagi quiz ke test ke soalan macam ni betul ah? Okay ah. Okay, sekarang madam random test. Abdul Hati.
Saya madam.
Okay, snap jawapan 18 anda bagi madam tengok.
Kejap madam.
Okay So since we discussed already question 18 and 19, right? We proceed with question 20. Who is presenting question 20?
Me, madam.
Okay, Nur Shahira. Okay, question 20. Question 20, madam semalam sudah cek jawapan dia. Rasa semua betul kot. So, dengar penerangan Nur Shahira.
Okay.
Kerja yang keras.
Okay. First, write the equation, which is copper plus zinc will form copper to oxide. Copper and oxygen is element. So from the element, it will become copper gas. So this is called as enthalpy of atomization. Enthalpy of atomization is from the element change to gaseous atom. The copper gaseous atom will form the cation by removing one electron, and oxygen will form an anion by add electron. The copper change to the cation gases in this form. And then oxygen anion in gaseous form also. Then from the ionic compound, which is copper to oxide. Next, enthalpy of atomization of copper plus first ionization energy plus second ionization energy plus enthalpy of atomization of oxygen plus first electron affinity plus second electron affinity plus enthalpy of lattice energy will equal to enthalpy automation. Then substitute the from the information given, and this will get the enthalpy of lattice energy is negative 4097 kilojoule per mole.
Okay, good. Okay, so over here, right, the working of Shahira 100% correct. Okay, thank you, Shahira. Okay. Okay, madam just want to emphasize a bit. Semua orang please pay attention. Soalan construct Born-Haber cycle is a famous question. Okay, everyone can see Madam sharing now? Okay, so make sure the unit, okay, the unit for the cycle all in kilojoule. Okay, the unit when you show this in the cycle, right, the Born-Haber cycle all in kilojoule. Okay, all from solid, okay, depends on not from element, okay, from element, it might be solid or gas. So for example, copper is in solid and then oxygen is in gas. That's all, solid and gas. Okay, then from this element to undergo atomization. After atomization, first IE, second IE. So certain time, right, it will combine, the first and second IE combine. Okay, for anion, okay, atomization, and then first EA, second EA. And then this is the lattice energy of formation. That's why when you solve the problem regarding dissolution process or solution process is the same, I encourage you all write down the lattice energy of formation. Because the lattice energy of formation, the unit sure is negative sign with heat release must negative. So the unit is kilojoule per mole because it's referred to this one. Okay, 1 mole of copper oxide. That's why the answer is negative 4097 kilojoule per mole. Substitution, formula, substitution, final answer with unit. This is the format when you answer for chemistry question. Formula, substitution, final answer with unit. Clear? Clear? You see, the formula.
Clear, madam.
Must follow this format. Okay. Question number 21. Question?
It's me, madam.
Okay. You can share screen now. Let's check what is the difference between question 20 and question 21. Okay, I mean Shamini. Okay, yes, can. Okay, I can. You can zoom a bit for your the Born-Haber cycle. Zoom a bit.
Okay, madam.
Okay, cuba zoom sikit boleh tak? Dapat zoom ke tak? Zoom. Nak nampak Born-Haber cycle tu lebih jelas. Okay, good.
Okay. Alright. For this question, it asks to construct a Born-Haber cycle for magnesium fluoride and determine its lattice energy. So here, element react with element, we form ionic compound. So we put enthalpy of formation here. So just put the data, negative 645 kilojoule, and here magnesium solid change to magnesium gas. Here this process is called enthalpy of atomization. So we just put the value from the data above, and from magnesium gas it added 1 electron, so it become magnesium plus. Here we put first ionization energy equal to positive 736 kilojoule, and next it undergoes second ionization, so it become it also added 1 more electron, become magnesium 2 plus. And next the chlorine here and become 2 mole. So the enthalpy of atomization we have to multiply by 2, and then here chlorine undergoes become
Chlorine undergo EA ni lah apa? Electron affinity.
Electron affinity. So it added
one electron become 2 Cl negative.
Okay.
So here we just connect the error back to the ionic compound.
Okay, formula
from
substitution, final answer.
Yes. From substitute back all the value.
Okay.
And then we get the lattice energy. Here we have to take note to put negative sign and the unit must change to kilojoule per mole.
Okay, thank you. I mean, bukan kita sengaja nak put negative sign. You kira-kira memang akan dapat nilai negatif Okay, you kira-kira memang akan dapat negatif. Okay, Madam nak tegur sikit Mg2 plus yang last kali. Mg2 plus gas, 2Cl negatif gas. Jangan lupa tambah. Jangan tambah.
Alright, Madam.
Okay. Okay, betul? Tak ada masalah. Ada soalan ke tak? Okay, perbezaan soalan 20 dan 21 ialah apa? Okay, you need to times 2. Okay, for the chlorine, the atomization and electron affinity for chlorine, because it becomes 2 mole already. Yeah. Okay, question 21. Let them share a bit. Okay, just now I need answer is exactly same as mine. Why we need to times 2? Because over here is 1 mole, now become 2 mole already. That's why you need to times 2. Over here 2 mole as well. Initially is 1. Okay, here 2 mole, 2 mole. That's why you need to times 2. Get it? Very good. So substitution, formula, substitution, final answer we do it. Okay, now we go for question 22. Whose turn?
Hi, Madam Amirul.
Okay, Amirul, please share your screen. Fine.
Can you see it, Madam?
Not yet. Okay, wait, you are presenting.
Can, Madam?
Tak lagi.
Can, Madam?
Okay, yeah, you are sharing. Amirul Haziq. Okay, yes. Okay, this is the question 22. Okay.
22. A bond-Haber cycle for the formation of calcium oxide is shown below. So, the first question is asking for what enthalpy change do delta H2, delta H6 and delta H7 represent. For delta H2 is first ionization energy of calcium. For delta H6 is enthalpy formation of calcium oxide. For delta H7 is lattice energy of CaO, calcium oxide.
Macam salah je. Kelas betul ke salah? Enthalpy H2 betul. First ionization energy of calcium. Memang kerana dia calcium jadi calcium plus. Okay, itu adalah enthalpy H2. Enthalpy H6 tu cuba tengok. Gaseous ion jadi calcium oxide. Jadi enthalpy H6 baru ialah lattice energy of calcium oxide.
Terbalik.
Ya, terbalik. Terbalik jawapan terbalik Jadi hilang dua markah dah macam tu. Okay, sambung B.
B, calculate delta H5. From the cycle, we know that delta H7 equal to delta H1 plus delta H2 plus delta H3 plus delta H4 plus delta H5 and plus delta H6.
Yep.
We substitute the values given and we get delta H5 equal to positive 697 kilojoule per mole.
Okay, correct.
Okay, for C, calculate the first electron affinity if the second electron affinity of oxygen is positive 844 kilojoule per mole. We know that delta H5 equal to electron affinity 1 plus electron affinity 2, because at delta H5 first oxygen will the electron become oxygen negative for the electron affinity 1, and for the second the oxygen to negative. So we substitute the value and we get the first electron affinity is negative 147 kilojoule per mole. And for D,
okay, good. Question D.
Would the value of delta H2 be larger or smaller for magnesium than it is for calcium? My answer is larger, because magnesium atom has less effect than calcium atom. Magnesium atom is smaller than calcium atom.
Okay, kelas. Kat sini kita tak payah cakap shielding effect apa. Kita ni cakap dua faktor je. Faktor dia ialah size dengan charge. Okay, we just need to talk about size and charge. Over here, calcium 2 positive, magnesium 2 positive as well, same charge, so not related with charge. So the reason is due to magnesium is a smaller atom, okay, smaller size. That's all. So meaning that it can closer to the nucleus and then bond more tightly. Okay, thank you Amirul Haziq. Okay.
Okay, madam.
Okay, now we proceed with. Okay, before we proceed with objective question, right? Okay, I want to show you all something. About question 18. Siti Aisyah nanti tunjuk jawapan anda juga lah. I nak tengok juga sekejap. I share. Okay, this is Amirul Haziq answer. Is it correct? For question 18, if this question 4 marks, how many marks Haziq will get? Halo kelas, kalau soalan ni 4 markah ataupun 5 markah, dia dapat berapa markah?
2.
Yes, pandainya, dia dapat 2 je, tak dapat markah penuh. Mengapa? Okay, dia tulis formula, dia substitute, kemudian dapat jawapan yang betul, negative 382 kilojoule per mole, tapi dapat 2 markah sahaja. Mengapa tak boleh dapat 5 ataupun 4? Okay, 2 out of 5. Why? Anyone can tell madam why? Haziq, boleh tahu tak kenapa dia tak dapat markah penuh?
Tak tahu madam.
Yang lain? Siti Aisyah, mengapa? Mengapa dia tak dapat markah penuh? Jadi madam dah tunjuk mengapa dia tak dapat markah penuh. Semua orang tengok soalan. Tengok ayat yang terakhir. Calculate the enthalpy of hydration of chloride in the... Ya, dia nak energy cycle. Wajib tunjuk energy cycle. That's why siapa belum buat pembetulan, tak tulis energy cycle, tak lukis energy cycle, sila buat catatkan you must show energy cycle, then only, okay, formula substitution, final answer with the correct unit. Take note, please take note. Question 18, energy cycle insist, because the question requests for energy cycle. Okay, thank you. Now we proceed for question number objective. Okay, we still got 15 minutes. Okay, question number 1, Houston. Okay, present.
Okay, wait
Hafiza Raihana.
Can you see?
Okay, yes, you just zoom a bit.
So
Okay, yes,
the
question
number
number
1,
future questions. So number one is, which of the following process is endothermic? So the concept or the meaning of endothermic is heat is absorbed by the system from the surrounding, which is so the answer for number one is A.
Why?
Which is O. In the solid state, becoming converted to H2O else because it is heating, which is absorbing of.
Okay, ice melting. This reaction is ice melting from solid become liquid.
By
So
the
bond.
surrounding, so it absorbs heat in order to make the ice melt. Yeah.
Okay, you haven't touched the keywords.
Bond, hydrogen bond.
What is the keywords? Bond? No, bond breaking. Bond breaking. Okay. For bond breaking. Okay, bond breaking. Yes. Okay. If you still remember tutorial question number 4 and 5, we are talking about the bond breaking and bond forming. So in this case, bond breaking, so you need to absorb heat first. Okay. The rest, okay, no. The rest is forming. Okay, forming CO2, forming H2O. Okay, forming H2O.
And is, yeah, bond forming.
Okay, BCD is bond forming. A is bond breaking. With question 2, yes?
Yeah. And this is the question. So now I will proceed to number 2, which is, which of the following is an exothermic process? So my answer is condensation of water vapor.
Yep, correct.
Because it is an exothermic as water condenses into liquid, which is because the losses energy in the form of heat. Because exothermic reaction is the definition of heat is released from the system to the surrounding. So this is actually bond forming.
Okay, bond forming. Okay, bond forming, condensation of water vapor from gas become liquid.
Yeah.
Okay, correct, good. Okay, thank you, Hafiza. Okay, next question number 3. 3 and 4, who's turn?
Me, madam.
Okay, Shazwani. Shazwaniza. No, Shazwaniza. Okay, share screen. You can straight away explain. Okay, very clear. Good.
Okay, you can see, madam.
Tadi boleh, sekarang sudah hilang. Okay, yang ini boleh. Okay, jelas.
Okay.
Clear.
Okay, for the question number 3, I'll straight away to the answer. The answer is B. A negative delta H responds to an exothermic process.
Yes. Why? Well, okay, very good. You state
Because as we know, with the exothermic process, the heat is released from surroundings and it has negative enthalpy. So as is stated here,
okay, good.
it also for number 4, we had given the balance equation 2Na2O2 in solid form plus H2O in liquid form will form 4 mole of NaOH in solid form and O2. So it had already given the heat 126 kilojoule. So for the first step, we have added the number of moles because it had given the mass 25 grams. So by using the formula as per molar mass, so we get 0.32 mole of Na2O. Then from the equation given, 2 mole of Na2O2 equivalent to 126 kilojoule per mole. So now we have only 0.32 mole of Na2O2. So the amount of heat released by the reaction is 20.2 kilojoule. So the answer is A.
Okay, the answer is A, correct, class? Okay, correct. Okay, very good. Thank you, Shawaniza. Okay, next question number 5 and 6. Question 5, who's turn? Jiha, right? Question 5, who is
Saya,
question
Madam.
5? Amira. Okay, question 5, Amira.
Amira.
Amira, dipersilakan. Dipersilakan.
Madam.
Yeah, share. Okay. Tapi kurang jelas
Madam,
besar.
can you
Okay, I can see your screen but just make it closer or zoom it. Okay, kurang jelas tak apa, you zoom sikit je. Yeah, better. Okay, yes, you can start. Okay, boleh. Boleh. Adjust sikit.
Okay.
Oh, I haven't. Try. Rotate your screen.
Rotate. Wait.
Pusingkan.
It landscape.
Bagi horizontal. Yeah, landscape. Okay, semua orang boleh bagi cadangan je. Bagi cadangan, bincang. Kalau tak stres, gila.
Okay tak?
Okay.
Madam, apa?
Rotate horizontally.
Button on the right. Orientation. Okay. Okay. Okay, done.
I think she didn't lock. That's why can should be able to rotate. You pusing screen anda. Dia melintang. Screen anda melintang. Cuba.
Cannot
Okay, never mind. You just proceed, can? Okay, teruskan je. Berjaya dah, Tania.
Yes, can you rotate? Wait. Okay,
You sudah horizontal, you pusing balik je.
Okay, number 5. A sample of aluminium metal 9.88 joule of heat when its temperature increase from yes. Okay, when it's
sekarang macam mana rotate?
3.2 degrees Celsius to 30.5 degrees
It's a nice problem.
Celsius. If the specific heat capacity of aluminium is 0.90 per gram degree Celsius, the mass of the sample is
sudah hilang. Amira, are you still here?
Okay, not the heat released by
screen kamu sudah hilang dah.
Reaction is equal to heat absorbed by surrounding. In case aluminum metal is from the information given, we have specific heat capacity and temperature change. We use the formula Q reaction equal to mass times specific heat capacity times temperature change. Just substitute the information given, arrange, and you will get the answer. Yes. Yes, madam. Sorry. Buka apa? Let's see. Buka frame. Macam mana?
Tak apa, teruskan. Okay. Semua orang dapat tengok dia tepat 7.3 degree Celsius is the delta T And then apply MC data, so the mass is 1.5 gram. Okay, 1.5 gram. So the answer is A.
1.5 gram. Yes.
Okay, correct. Question number 6.
Okay, question number 6. Choose substance with enthalpy of formation not close to 0. Enthalpy of formation will close to 0 when it is pure element. So,
okay, the answer is donkey because A, B, C,
iodine,
O,
sodium, and bromine is not pure element. So the answer is D.
carbon dioxide. Okay, thank you Amira. Lain dia problem sikit lah, tak apa. Good try. Okay, now we proceed with question 7 and 8.
Yes.
Okay, terima kasih Amira. Okay, 7, 7, 8. Whose turn?
Saya, Madam.
Okay, Rabiato. Okay, share screen.
Sekejap Nampak?
Tunggu Okay, you are sharing your screen tapi tak nampak hasil kerja anda lagi. Okay, sekarang nampak. Putih lagi.
Sekejap Sekejap scroll.
Rabiato guna handphone ke laptop?
Guna handphone, Madam.
Okay, good. Walaupun dia guna handphone tapi jelas nanti pergi cari Rabiato mengapa boleh share dengan jelas kalau guna handphone Okay. Okay, 7 answer is C.
Saya continue sebab okay. Next thing sebab from the definition has flow state when reacted are converted to the product. The change in enthalpy is the same whether the reaction take place in one step or in a series of steps. So
okay, betul. Why so happy?
Okay.
8.
Okay, question number 8. Okay. First, given ada salin soalan boleh ikut tengok. Okay. And then the target equation adalah 3Fe2O3 plus CO dapat CO2 dengan 2 Fe3O4. So,
okay, betul.
Kita nak bulatkan mana yang terlibat dekat target equation. So, kita tengok dekat target equation 3Fe2O3. So, so kita darab 3 dekat first equation. So, yang second kita tengok yang 2Fe3O4. So, sebab tu darab 2 dekat second equation. And then kita bulatkan mana yang terlibat dalam target equation. So dapat jawapan dia.
Okay, betul. Jawapan dia ialah C. Okay, very good. Follow method. Tapi yang last kali enthalpy of reaction soalan dia lah enthalpy of reaction bukan formation Okay, thank you Rabiato. Presentation yang so joyful Okay, next question 9 and 10. Behave a bit, Roberto. Okay. Question 9 and 10. Who's the last question? Okay, last discussion for today. 9 and 10. Siapa? Off mic dah, Roberto. Okay, last question. Question number 9 and 10. Siapa? Who haven't present yet? Siti Husna dah. Oh, you're 9. Sorry Okay. Okay, question number 9 is C. Why C? Okay, enthalpy of neutralization is the release when 1 mole of aqueous H plus with 1 mole of aqueous hydroxide, meaning there is 1 mole of acid with 1 mole of base or alkali, and then we form 1 mole of water from the reaction of acid and base. So the answer is C, 2 and 3. Question 10. Choose the correct statement. The correct statement is only 1. So the answer is A, 1 only. Ionization energy is always positive. Okay, but for electron affinity, might be positive or negative. Enthalpy hydration, hydration heat release, so sure is negative. So the answer only A, 1, Roman. Okay, so very good. Every one of you participate for today's lesson. Okay, no matter how. Okay, later I will share a YouTube video with you all because I am YouTube live now actually. Unlisted. So later you can check your presentation. Okay, before end our class, right? Okay, everyone please give yourself a clap, congrats, because every one of you able to present. Hey, Amiru Habib, so supportive, okay? Terima kasih Amiru. Okay, cukup dah Piato. Okay. So, hari ini Madam sudah habis perbincangan chapter 2 Thermochemistry. So, anda pergi tengok dari soalan 1 sampai soalan 22 dan objektif soalan 1 hingga 10, semua tengok semula. Yang mana minor mistake, tak faham ke apa ke tak apa. Bulatkan tanya. Yang janji sekarang you kena lengkapkan 32 soalan ni. Okay, cuba lengkapkan semula, check semula. Okay, yang salah tu betulkan dengan pen merah. Okay, yang tak faham boleh PM Madam, tanya juga. Okay, so next Monday right morning, I want you all complete your tutorial. So that's why morning 8 o'clock no class, because that hour I want you all to prepare, complete your tutorial and get ready. Maybe there will be a objective quiz. Okay, maybe an objective quiz for chapter 2. So just get ready and please check your Google Classroom. Okay, please check your Google Classroom. Turn in all the homework. Okay, yeah? That's all for today. Thank you.
Thank you.
Thank you, madam.
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 Hi, madam.
Thank you, madam.
Thank you, madam. Thank you, madam.
Okay.